Hello everyone. In this video lecture, we are going to learn how to solve a three-variable K-map. By using the K-map, we are going to find a simplified Boolean expression. Now here, this is the question. Simplify the Boolean function. And function, they mentioned here, function of x, y, z is equal to sum of minterms are 2, 3, 4, 5. Means in this three variable function, the minterms present here are m2, m3, m4 and m5. And regarding these minterms, binary sequence we can write as for m2 0, 1, 0 and that respective minterm we can write it as x complement, y, z complement. And coming to M3 midterm, the binary sequence 0, 1, 1 and regarding that product term expression x complement and y and z. M4, the binary sequence is 1, 0, 0 and respective product term is x and y complement and z complement. Now here for M5 midterm, binary sequence is 1, 0, 1 and regarding product term or minterm is equal to x and y complement and z. Now when we are solving a three variable function to find out simplified Boolean expression, we need to use a three variable K-map here. Now this is the three variable K-map and whatever the variables they mentioned in the function, we need to consider to row side and column side also. Here we are considering x variable to the row side. For the first row, x complement variable will be common. For the second row, x variable will be common. And coming to the column side, we are considering yz variables are common. And for the first column, y bar and z bar is common. For the second column, y bar and z bar, y bar and z is common. For the third column, y and z is common. For the fourth column, y and z bar will be common. Now, firstly, we need to assign ones for the minterms which are present in this function. Now, we observe that minterms m2, m3, m4, m5 are present in the given function. Now, we are assigning 1 to that respective minterms. So here M2 minterm is mentioned. So for this cell, we need to assign 1 here. Coming to M3 is present here. So assign 1 here. M4 is present. So here we need to assign 1. And coming to M5 and we need to assign 1 in M5 place. Now secondly, we need to combine the adjacent squares in this three variable K-map. Now if we see this three variable K-map, this M4 minterm and M5 minterm squares are adjacent to each other. So, and coming to this M4, here there is no 1 here and here also there is no 1. So we are combining only two squares as a group. So these two minterms is going to form one group. Nothing but here this is a rectangle. And here coming to this M3 minterm and M2 minterm are also adjacent to each other. Then we can make another group here. So by combining M3 and M2 minterms, we are making another group. So in this format, we need to combine the number of adjacent ones in this three variable K-map. Now we will write separately each product term for each group here. Now for this group, we are combining M4 minterm and M5 minterm. And M4 minterm expression will be x, y bar, z bar. Now we are writing that here. And M5 minterm expression will be x, y bar, z. Now by considering that x, y bar, z, by considering these two product terms, here x, y bar variables are common here. So x, y bar will be common and z bar plus z will be equal to 1. Now for this group, the product term will be x and y complement. Coming to this group, we are combining minterms m2 and m3. We know that m3 minterm expression will be x bar yz. Now we considered here, and m2 expression will be x bar yz bar. So in these two product terms, the common variables are x bar y and z plus z bar will be equal to 1. So for this group, the product term will be x bar y. When we are combining adjacent ones, here we need to observe the common variables. Directly, we may write the product term by observing the adjacent ones. Here if we see this group, here the x variable is common. So in this product term, definitely the x variable will be present. And coming to these two ones, we need to observe two columns here. So for the first column, common variables are y bar z bar. For the second column, the common variables are y bar z. So here in these two columns, the common variable is y bar here, y bar also here. So and leftover other variable z bar in the first column, z will be in the second column. If we observe, the z variable will become 1. So when we are combining adjacent ones, we need to consider the common variables. Like here x will be common and y bar will be common. So the product term for this group is going to be x and y bar. Now coming to this group, by seeing itself, we may write the product term directly. Considering x bar as common variable for this row and coming to the third column and fourth column, y variable will be common, z variable is changing from z to z bar. So the common variables are x bar and the common variable is y. So the product term for this group is x bar y. Now, by adding these two product terms, we may find out the simplified Boolean expression for the mentioned function. So, the simplified expression will be equal to first product term x y bar plus second product term x bar y. So, this is going to be the simplified function for the mentioned given Boolean function. Thank you.